Hey everybody, this is TJabs. Welcome back to Replicube. Today we're going over the last of the puzzles that I have personally done beforehand, the kind of ones that I did that made me want to let's play this in the first place. But before we jump into that, something I wanted to do because it was mentioned by a comment that I got by someone named BlueMax. So thank you, BlueMax. They actually had a lot of good tips about formulas and things you can use for distance and circles and squares generally. Clearly they have like some of the geometric things down, but something they also mentioned was something that I didn't really talk about is there's a puzzles of the week where we can just see things that were made from different puzzles of the week. Cool. And hey, there's like a leaderboard specifically for those. So there's one that I did where I'm in the leaderboard, right? And hey, I'm in the top 100. That's cool. These are time sensitive. What I didn't realize as I was kind of playing through these puzzles, as I was kind of seeing them play out, was that you can view the code, and there's a nifty little like spoiler thing. You can also just see the code. So if I want to see what somebody did for small code at the very smallest thing, here's code that's 25, and it's one line, and it's complicated math, but it gets there. How's our fastest code? How does that work? My guess is that it takes quite a bit more than one line. Sure does. What the hell? Square to the power. Okay. Sometimes you have to not worry about why you didn't wind up in a spot. I'm guessing that that's a mathematical function. Like that's something times pi to a certain number of places or something. And that's what that number is. Whoa. These are big. Whoa. So if this is like if x, it's like weird slices. It's these like weird slice things of the final project, which was, if I go back again, this was Patterned Planet, which I did do. Okay. So yeah, like somebody doing that like showed off how they were able to do it, and this one was like a diagonal symmetry thing. So that's a good call out, and it's part of what makes this game cool, right? Part of doing this project is wanting to create, ideally, a thing where people can celebrate with what they're doing right, where they can ask for help if they're doing something wrong, and also just to make code seem not scary. I've been thinking about that a lot. I've been like doing coding stuff for work. I don't code by nature, and I made a video game. Have I said that? I made a video game. So I've done like coding as like a self-taught thing, and I think we owe it to ourselves to be a little bit kind. This is not the problem we're on. We're on stairwells. This is one I've done before. Let's not talk. This one I was proud of because we have this little stairwell. So let's just jump right in. We obviously have like this sort of, not rotational symmetry, a kind of symmetry. We have, on z equals 0, we have a dividing wall. And then here we have things going 5, -5, 4, -4. So basically, if x times -1 equals y, and then on this side we have if they're equal. So the very simple thing that we could do is say if z equals 0, then, and just return that wall, right? So then I could say, so let's see, if z's positive, then they work together. If z's negative, then they whatever. So if I say return, if I say if, or no, return y. Here, wait, if I do return y times sine, I can say sine, right? Sine's a function? I hope sine's a function. It is. Sine of z y times sine of z equals x. Right? No, that doesn't work. What are we seeing? Oh, because I didn't close the parentheses. Ah, and then this is the wrong color, but it's the right shape. So if I do this whole thing, oh, and then add 1. Oh wait, no, if I have to do it around the whole encompassing thing, right? Because that's 1. If I say plus 1. I say times 2. Because that really we just need to double the color. Whatever, I can do if, then hey, this is not my optimal way of doing it, and I kind of wanted to show it a slightly different way, because I'm really proud of what I did. This is actually not the fastest way either. This was the fastest. So this was my smallest code here, which is, okay, the same thing. If z is 0, do this thing. And then I basically took this idea of y times the sine of z and did btoy, which is like, basically, if it's true, return 1. If it's false, return 0. So you get the same mathematical thing. This is a little bit faster to do it this way. So it is an improvement. It's not the fastest I did. The fastest I did was actually just to slice it on either side. And I think that something I hadn't thought about before, and something I need to think about in my code, and because this one's pretty quick. Like if I go and submit this one, 6.335, like that's in, like, you know, pretty good. I say it's on page 74 of, you know, 130, but like it's one cycle off. Like there's sort of a logarithmic function when you get down here into the later half. And also, it's, you know, I like the idea of comparing here. Not so much in the sense of you need to be better than people, but it tells you, like, is your solution common? Is your solution unusual? I kind of think that's more valuable than it is to say, hey, your you know, solution, like, don't you want to be the best? Everything I've seen from code is like, look, computer processors are crazy. Yes, you want to be efficient. And if you're doing something like a sort, you need it to be within like a certain operational parameter. Like if it scales logarithmically with the things you have to sort, you have a problem. But like most of what you need to do to make good code in this world is make it so that it's scalable, is like kind of the thing with the sorting, and then also understandable by a human. And if you're doing those things, you know, as far as I can tell, you're coding how you should be coding. So that's something that I've been thinking about a lot too, And this game has sort of been a good reflection of that. But the good news is that's the last one I did that I had seen before. I mean, I guess I've seen these problems, but now we can start to look at these problems, you know, and I'll be solving them for the first time, which I think could be like a fun little C problem solving in action. So we have this tiny little chair. Chairs and tables are fun because they're so symmetrical. Notes: look for symmetry and use absolute value. Right? Which makes sense because like this and this are the same. So if I say if absolute value of z equals 1, you know, then it's pretty easy to do different things. I totally missed a point. Oh yeah, I have an old code here, but I didn't solve it. I just started to like slice things out. So the way I see it, there's a couple of things that stick out to me on a chair. Which is, obviously, there's like, you know, obviously we can do it as like, hey, this repeats this H. We could create an H, and we could create another H, and then bridge the gap. And that should work. The other thing that I'm seeing is this U shape, right? This U is here because it's not just the bottom, it's also the back. So like if you could create this U, if you could create a function for this U, which should be doable, right? We could create a function that basically just places these where they need to be. We would need to think about mathematically what's happening. So these are a two-dimensional shape. So we would kind of need to put in the vector, or like the vector of it. So like in this case, it's an X and Y U shape. So we've got that. Let's see, it's like if we had like 0, you know, 0, -1 here, but like if this is 0 and 0, it's actually always Y. More think about it. So it's the horizontal is X or Z. So for a point, if we said 0, 0, if this was at 0, 0, then we need to go -1 and down an additional 2, and +1 and down an additional 2, and return those and not return the middle. So let's try and play function U shape, and I have to return a vector, right? I have to return direction. I don't need to return Y for this, and then I need let's call it D point, and then Y point, and that will be kind of our origin of what we're passing in, because that'll tell us should tell us everything that we need to know to do the math. How do I know I can name a function. I'm still learning Lua and like what I need to do. Is it a curly brace? No, it's just an end. Okay. So now I need to basically should be able to do kind of like it does here. Like if I return it within certain ranges, then that should be good. That should work. So let's go back here. So if I say function U shape, let's think of this first as a Boolean. That's kind of what I know. That's what makes sense to me. So we'll think about this. The first thing it should do is it should return the center. And it's fine. And this is ands, but ours should be ors. But we're still doing kind of a Boolean function. So I should say return. We'll do these with parentheses to make them a little more readable. Dir equals dir point, and y equals y point. Or dir equals it should be, I could use an absolute value. The absolute value of dir. If I do this, if I say the absolute value, oh, I'm cooking now. I can feel the problem being solved. The absolute value of direction equals dir point plus 1. And y, and in range, y should be y point minus 2 and y point. So that should return, right? Okay. So let's say, if I say U shape, let's do this. X 0 0. What's the matter? Line 3, attempted to perform an arithmetic on a nil value. Global dir point. Do I have to parentheses this? This might be a sin. Oh, D point. It's D point. Whoops. It started to say. Okay, this is running. Oh wait, if U shape X 0 0, return 8, just to get a thing. All right, that's not returning. Do we got a 7? Syntax error. Oh, didn't say then. Okay, hang on. Ooh. Oh, so this creates it, but it doesn't. Okay. This creates it. We've created the U shape correctly, and we can use this code. What we can't do is use it as willy-nilly as we have, because then it goes back into infinity because we didn't consider the other direction. That's right. So, but if I say, on the Z, if I say U shape equals this, and the absolute value of Z equals 1, then we should return correctly. I didn't put an and. Aha. Oh, that feels good. All right. So then if I say if U shape X, and what's this origin point? 0 2 2, and Z equals 1, then we return 8. Z equals -1. And then literally all we have to do is add in this little 3 top, and we are golden. So what we can do is say, if z equals 0 and y equals 0 and x's and in range x -1 1, whoops, then return 8. Should give me the oh, is this too high? Wait, that's oh, I don't have it high enough. U-shape 3? Ah. Now I am. What have I not done in this shape correctly? This is all correct, right? Show comparison. What am I missing? Overall match. Oh, I have the there's a height issue here that's occurred. The shape should be down 1 more. So if I say with a U shape, I say -3. Oh, that's not right. No, it's -2. That U shape's correct. This I talked about it. This is for Y. With Y, it starts at 0 and goes down, and that's correct. That's all correct. No, it does go down further. I'm just looking at it. I'm looking at it and I'm seeing it wrong. This is at -1. And this is at 0. Oh, I'm looking at my own and doing that as the reference. Lord have mercy. If I say -1. Okay. And then if I say when Y equals -1. Okay. Oh. Okay, and then this goes back down. Okay, that was just a little kerfuffle there. Nothing too serious, but hey, we matched it. So we'll go ahead and submit that in. Let's see. Code-wise, this is both one of the biggest solutions. Oh, we got an email. It's one of the biggest solutions, and it's also one of the slowest solutions. So let's try and do this differently. And I think we can actually use some of the same code and still improve it dramatically. Because I think I see something that we can do. Let's say, so if I realize this is just equals 1 or x equals -1. So rather than do U shapes, okay, because now what if we just cut, you know, this shape and let's, okay. I'm actually going to steal this function. I'm proud of this function. Maybe this function is not the way we want to do things, but we're gonna use it here. I know. And because this is on Z, so we don't have to worry about X at all. So if I say if U shape Z 0 0 whoop -1 then and return 8. Gets us that shape going. We can do more here. Can't we? Like we've immediately sliced it there and done those U shapes in a should be a much quicker way. Because we're not hard coding in each one. We're only hard coding in. No, I don't actually know that this matters. You know, we're not going to worry about it just yet. We're not going to worry about it just yet. We don't have to worry about it just yet. Okay. And I said if c equals -1 and y is less than 3, return 8. And remember to say then. This is all we have to do is add in these little bridge gaps. And we're good. If I say if x equals 0, then if then I should probably do some math. If y equals 3 and z equals -1, then return 8. Oops. Let's send that back there. Thank you for indenting, video game. That gives us a little bridge gap. Let's bring this down one. And then if I say if, oh, and then I can do if y equals -1 and in range z -1, 1, then return 8. That is less than a third of the time to do that. And the reason I think is, okay, we sliced a little more efficiently and we didn't have to use U-shape a whole bunch, which I realize means that doing this code at this point doesn't really matter. We should submit this because it's much faster. It's a little bit bigger. I did not make, and it's still not in the plurality. The plurality seems to be 8 cycles, which makes me think that it's probably, there's probably something else that I could do. Maybe it's that I return zeros, like I return this cross shape as a 0 and do this. But like this is where I'm happy. We were on page like 100 and I forget. We were way out there on cycles, and now we are significantly better. In terms of size, this was not better. This was in fact worse. But I think, yeah, we sliced it better and we didn't do as many operations because we were using these like X things more clearly. And the other thing I'm thinking, I always thought like, oh, if I got things out of the way, I should be... This doesn't speed it up if I move this, right? This has been something that I keep like second guessing. No, it's about the same. It's about the same. So now we get this thing. If I go comparison, oh wait. Well, I'm not going to worry too much about it. I submit. It should still keep my best. Yeah, we went from 38.5 to 12.4. What an improvement. 92 is still very big. There are bigger code sizes. Usually at the end, somebody's done something in what feels like intentionally very big. 26 is the smallest. So we're about 3x the size of the code. I wonder if it's an H shape. Right? Because I could actually... If I did another code, and we'll make this be what we explore a little bit. If I make this function U shape, and I do H shape, because I have right now it's like it's doing a, if I said like this, if I said, yeah, so if I said, okay, so right now I return a U, so I just look at and I go, you know what I gotta do? Okay, so this is Z, so this is Z, so it's blue, it goes +1 or -1 up 3. Okay, so I could do, if I extend this out, right now I'm doing absolute value of direction, or direction -1, direction equals D point -1, and in range Y, and that's if this is the point -2 or +3, Y point -2, Y point +3, or direction equals D point. Wait. Did I close off the parentheses correctly? Yes, I did. Or direction equals D point +1 and in range Y, Y point -2, Y point. Okay, that code should run. So if I say if absolute value of X equals 1, absolute value of X equals 1, and H shape, an H shape on Z with 0, -1. And return 8. Oh, look at that. if x equals 0, and so now I just need this little bridge. If y equals if y equals -1 and absolute value z less than 2, then turn 8. This isn't going to be smaller, is it? Yeah, because this is already larger. Fiddlesticks. Okay. Beans. But I did make an H shape, and that's pretty cool. It's also more speedy. I feel like speedy code just vibes with me better. I'll go ahead and finish this one out just to say I did a solution, but it is weird to make a smaller solution and then make that solution bigger. I could probably save some size if I just like hard-coded this. Because I'm using a lot of functions. And I could probably condense that by writing it down. Is probably what that means. Like, it doesn't need to be a function I only call it once. Whereas at least the other one I called twice. Okay, so with that in mind, now I just gotta bridge that gap. If x equals y, if y equals 2 and z equals, that's what, -1, I think. All right. It was bigger. It was actually bigger than our code. That's okay. So, you know, I got to do a new puzzle here. And we did improve it. We did improve from our first thing. I need to... for those who wonder, code size is a little bit interesting. If we look into scoring, there's this idea of code like tokens, basically. So it's like strings have like a cost to them, numbers have like a thing, but like operators like have different like token amounts. So it's odd. Like, and numbers do this. I think it's odd. I don't know if these count as like strings in this operator, like if making the function smaller would do anything. But yeah, it's like this odd thing of every operator is a point and then bigger numbers and parentheticals and stuff. So there's like a certain amount of cleaning your code, but also you can make some real jank stuff. Let's go ahead and see what that email was. Unlock your creativity. Thank you for showing so much interest in Replicube. In order to create your own objects, you need to activate the Voxel app in free edit mode. I've attached a script that should unlock it for you. I'm excited to see what you create. Just open the Replicube app from the launcher at the top of the screen to open it in free edit mode, where you can freely make your own creations. You can save them and load them later from the Files Manager app in the My Free Edit Projects section. Neat. This is... oh, is this just I can make my own stuff? In this sandbox mode, you can create your own objects. Yeah, animations. Yes, if you turn on animated, your code will run multiple times to generate multiple frames of animation according to the frame count, and played back like a stop motion animation at specified frames per second. In your code, make use of the T variable to generate differences for each frame. Oh. Ooh. So that's like, okay. Let me, I wanna touch that right now. How do I turn on animation? Is it one of these buttons? No, that's the grid. Oh, I hate that. Oh, it's so I can do it orthogonally. No, thank you. This makes more sense to me. Oh, and that's reset. How do I turn on? I'm sure I can figure it out. If you turn on animated, I'll have to figure out where to... Oh, animated. Aha! And then if I say frames, if I say 6 frames, 8 frames, if I return where x equal z equals t, yeah, and if I say -3, oh, that's weird, but cool. Oh, that's fun. Okay, let's look at the other email we got. Alice from Retrotech. You didn't seem too troubled by my first sets of objects. Here are a few more. These should be slightly more challenging and also cute. Whenever I look around my house objects, I immediately imagine how I might make them out of cubes. Let's see. Oh, we got lots of things. We got a doggo. Oh, man. Well, you seem easier than... You seem a little bit easier than the whole thing with the duck. Lots of x-axis symmetry. You can use mat to make boxes and frame shapes. Also, adding coordinates usually makes a diagonal line. Huh. Interesting. You know, that's the thing that I didn't think about, is that the game would give you more wisdom as you go along. Some of the people who went and optimized these things, it's also worth noting that they may have beaten the game and come back and optimized them. Not a flower. Ooh, okay. We're gonna get some fun ones in here. Puzzle. Okay, does it go all the way in, or is it hollow? It's hollow on the inside. Yeah. Hell yeah. Okay. And a cute computer. Oh, that's fun. It's playing Pong. So I think next time we can start to tackle these. We'll probably go to this one that we didn't do here in Strawberry. It's got a funny little internal shape. I don't know if we'll do every... You know, they're adding puzzles to the game all the time. I'd love to create my little kobold self in this, but that'll take some doing. A tiled room. Whoa! Okay, it's more big than actually a problem, but... Okay. This is one where we'll have to start breaking down. Okay, I'm excited to get to do some of these things. But that'll be fun. It'll be fun to do that. Yeah, I'm having fun with this so far, and I hope y'all are too. I hope people are enjoying watching someone who's an amateur coder take a crack at these shapes. Hopefully we can keep doing cool things here, and hopefully this game keeps seeing things, because I want to see stuff like this where people are talking about the ding dang video game in a forum that exists in the video game. That's sick. But I'll leave it there. So, you know, hey, if you saw any of these things and you want to tell me how you did it, or you want to tell me what you think of my code, or if you learned something from that, or you saw a different problem solving technique, love to hear from you. But with that, I'll say goodbye, and I'll see y'all in the next one.